The next question is question number 9, which reads as figure 2.42 given below shows a velocity time graph for a car starting from rest. So the initial velocity is 0. The graph has three parts: A, B, B, C and C, D. So it has three parts: A, B, B, C and C, D. A, B shows acceleration, because since it is a velocity time graph, so any line which has a slope uh, and which has a slope more than 0, and it makes an acute angle with the x-axis, it is having acceleration. And here if you see BC is a flat line, and it is parallel to the x-axis, which suggests that the body is moving with uniform velocity. Velocity is not changing. And the last portion CD here, which is a line coming down, which should have a negative slope, so this portion shows retardation. That means the body is moving faster, then the body moves with the uniform velocity, and then body slows down and comes to rest. So from the graph, you're supposed to solve a few questions. State how is the distance traveled in any part determined from this graph. So you know, from velocity time graph, if I want to find the displacement, I am supposed to find the area enclosed by the graph. So the first answer will be, as it is given in the book, by finding the area enclosed by the graph in that part with the time axis. So the answer lies in the book. Number 2, compare the distance traveled in part BC with the distance traveled in part AB. So for this question, what we are supposed to do is, we are supposed to find the distance traveled in part BC, and then the distance traveled in part AB, then divide those values and get the answer in ratio. So I've done here. So the first one, the distance traveled in part BC will be the area of the triangle BCFE. So here in your book, F and E is not given. I've just mark this point as E and this point as F, because it will be easier for me to represent as a figure. So area of rectangle BCFE, whose value is length into breadth, whose formula is length into breadth, and the length value, what will be the length value will be is 2t minus t. This is the length, and if I consider this as the breadth, then it will be v0 minus 0, because this length is v0 minus 0. So hence I have written here length as 2t minus t multiplied by v0 minus 0. So 2t minus t will give me t, multiplied by v0 minus 0 will give me v0. So if I multiply this two, I am getting v0 t. This is the distance traveled in part BC. Now I am supposed to find the distance traveled in part AB. AB is for AB, if we consider this portion, so the area enclosed will be the area of a triangle ABE. So distance traveled in part AB will be equals to area of a triangle ABE, whose formula is half into base into height. So half into base, again I am supposed to find the base here. This line is t minus 0, so hence I have written t minus 0 here, multiplied by height. Height is again v0 or v0 minus 0, v0 minus 0 or v0 minus 0. So again solving it, half into t minus 0 means t, multiplied by v0 minus 0 means v0. So if you solve this, I am getting half v0 t. Now thus comparing, we get the first value was v0 t, the second value is half v0 t, v0 get cancelled, cancelled, t gets cancelled, and hence I am getting 2 upon 1. So the ratio will be 2:1. So this is answer number 2. Let us see question number 3. The question number 3 reads as, which part of graph shows motion with uniform velocity? Okay, then acceleration and then retardation. As I've discussed earlier, the first portion shows the acceleration, that is AB shows the acceleration. The second one, BC, which is parallel to the x-axis, shows the uniform velocity, and the last portion CD. So the for the graph is the slope was negative, the slope was coming, the line was coming down, that portion shows the retardation. So the answer is given here in the book. Number 3, BC shows uniform velocity, AB shows acceleration, and CD shows retardation. Now going to number 4, is the magnitude of acceleration higher or lower than retardation? So magnitude means is the value of acceleration lower or higher. For that we are supposed to find the acceleration from velocity time graph. So I've done here for number 494b, acceleration in part AB. So whose formula is a equals to v minus u upon t. So a equals to v, the maximum of a equals to v naught, that was the maximum value, minus u, which is whose value is 0 because the car originally started from rest, divided by time. So AB portion, let me see, if you consider the graph here, the AB portion, the time is from 0 to t, hence here while calculating I have used t. So retardation in, so the answer will be v naught t. So retardation in part CD. So to find the retardation in part CD, since it is coming down here, the retardation in part CD will be again a equals to v minus u upon t. So a equals to v minus u upon t. So v is 0 because final velocity comes to rest, and u started from v naught here, v naught. So it is 0 minus v naught upon t. Let me take the value of time. So here the value of time will be this portion. This portion is 2.5 t minus t. So this portion, so 2.5 t minus 2t, sorry, 2.5 t minus 2t. So if I solve this, I'm getting minus v naught 0.5 t. So retardation will be v naught upon 0.5 t. So because since this a was acceleration, so comparing again, we are supposed to divide the first value with the second value. So v naught t upon v naught 0.5 t. If I solve this, I'm getting as 1 upon 2, hence the ratio will be 1:2. Hence the ratio will be 1:2. Hence the ratio will be 1:2. But that might not match with the answer which is given in the book. It matches. I'm just confused with this. It matches here. It is 1:2. So this is number 9.